300 hours, the sky over Tehran lit up. But here's the part most people don't understand. By the time the first blast echoed through that city, the battle for the sky was already over. Because hours earlier, radar screens inside Iran's air defense network had begun to flicker, glitch, then disappear. And somewhere above the darkness, flying without afterburners, without contrails, and without warning, two aircraft types were already in position. The F-22 Raptor and the F-35 Lightning. They weren't there to escort bombers, and they weren't reacting. They were shaping the battlefield, and they didn't act alone. For months, carrier strike groups have been sliding into position, tankers have been surging to forward bases, and stealth assets were quietly moving across Europe and the Levant. Diplomacy had collapsed 48 hours ago, but this morning, this was something different. This wasn't a warning shot. This was actually the first time that we've seen a full-scale 5th-generation strike architecture actually flex its muscles. And here's the question we're going to answer today. Did Ordnance win this fight, or did the stealth fighters make it impossible for Iran to fight back in the first place? And at the end of this video, you'll understand why the real story of February 28th isn't about explosions over Tehran. It's about what happens in the invisible hours before sunrise. Before a single Tomahawk left its tube, the board was already set. Think back to late January. We've talked on this channel about the USS Abraham Lincoln sliding into the northern Arabian Sea. To get there, they went dark, transponders off, and quiet. Just 2 weeks later, the USS Gerald Ford shows up in the eastern Mediterranean. Now, you've got the geometry. 2 carrier strike groups, at least a dozen surface combatants, an unknown number of submarines lurking below. This wasn't signaling, this was a chokehold. And then, the airframe started moving. F-22s from the 1st Fighter Wing staged throughout the UK. F-35s reinforced the theater. C-17s and C-5s were pulling non-stop shifts to build the mountain of supplies needed for what was coming. But here's the detail that actually matters. The tankers. When you see KC-46s and KC-135s landing under cover of darkness, you know things are going to get serious. You don't deploy tankers for headlines, you deploy them for sustained high-tempo combat. By February 26, the zero enrichment talks in Geneva had hit a wall. Iran said no. 48 hours later, the skies over Tehran turned orange. Now here's the part that most coverage is going to miss. Operation Epic Fury did not begin at 0300 hours. It actually began weeks earlier, when stealth assets and crews were quietly distributed across the region. Now put yourself in the shoes of an Iranian commander that morning. Your electronics are haywire, your comms are trash, explosions are starting in the distance, and you've got 2 choices: stay on the ground and get hit, or launch and fight. And that's exactly where the F-22 Raptor ruins your day. Days before, 11 Raptors moved into Ovada Air Base in Israel. And let's be real, they weren't there for a photo op. At 50,000 feet, cruising at Mach 1.8 without even using afterburner, the Raptor is essentially a God mode umbrella. It doesn't need a ground radar grid to tell it where the enemy is. It brings its own. Remember, air superiority isn't about dogfights and Hollywood maneuvers. Most of the time, it's about deterrence. If an Iranian MiG-29 or Su-35 even tried to get off the ground, the Raptor sees it, tracks it, and neutralizes it before the pilot even knows he's being watched. First look, first shot, no second chances. So while the F-35 was busy fracturing the radar grid below, the F-22 was making sure nothing in the air could fix it. Chaos on the ground, total clarity in the sky. And here's the quiet truth. The most important combat victories are the ones that never happen. If no Iranian interceptors meaningfully challenged the strike package, it wasn't luck, it was design. Which brings us back to the through line. The ordnance was visible, but the architecture was invisible. And the architecture is what made resistance nearly impossible. And now the bigger picture starts to emerge. Because neither the Raptor or the Lightning operated alone. They were nodes, connected and sharing, feeding a strike ecosystem that stretched from carriers at sea to tankers over Israel to missiles threading through Iraqi airspace. So the question becomes, was this an airstrike, or did we just see the first large-scale demonstration of a fully networked 5th-generation war machine? That's where we're going next. The system, not the strike. People call the Raptors and Lightnings fighters, but in 2026, that's the wrong word. They're actually flying data nodes. During the strike, everything was plugged in. Carriers with their growlers provided the electronic noise. Tomahawks followed pre-mapped digital hallways, and drones provided affordable mass to distract the remaining sensors. When an F-35 neutralized a radar site, that info didn't stay in that cockpit. It flowed to everyone. So when the heavy hitters, the F-15E Strike Eagles, pushed in with their massive payloads, they weren't flying blind. They were moving through corridors that the stealth jets had already scrubbed clean. And that is the shift. This is really the difference between 1991 and 2026. In Desert Storm back in 91, we suppressed defenses in waves. Today, dominance and destruction happen at the exact same time, and in many cases by the same airframe. It's one organism that's got 100 limbs. And this is the moment where the original question starts to answer itself. Did the bombs win this fight, or did the architecture make that resistance irrelevant? Because when radar is fractured and interceptors are deterred, standoff weapons arrived in synchronized fashion, and it makes the strike almost procedural. Which leads us to something important. Wars don't end when the bombs land, they escalate. And within hours, Iran had answered. Now the system would be tested in reverse. At 0300, stealth fighters were already inside contested airspace, but hours before that, someone was turning wrenches in the cold. At forward bases in Europe and the Levant, maintainers worked through compressed timelines, while fighters surged across continents in mere days. Jets that normally live inside climate-controlled hangars were prepped under expeditionary conditions. In fact, one Raptor reportedly turned back early in the deployment cycle due to a technical issue, and that's the part that doesn't make the headlines. But what matters is that that same jet was repaired and returned to the flow. Because while the F-22 Raptor and F-35 Lightning are extraordinary in the air, they are very demanding on the ground. You've got those low observable coatings, sensor calibration, and incredibly tight tolerances. What that means is that every sortie depends on the crew chiefs who sign their names on that aircraft. And then, of course, there are the pilots. Imagine climbing into a jet knowing your job is not just to fly, but to control the first hour of war. F-35 pilots manage sensor fusion, electronic attack, and targeting flows. Meanwhile, Raptor pilots operating high above the fight ensure that no hostile aircraft ever closes the distance. There were no fireworks, no cinematic dogfights, just calm decision-making at 50,000 feet. And let's not forget those tanker crews. KC-46 and KC-135 crews were flying predictable tracks in a very unpredictable environment. They were there to extend range, extend options, extend time on station, and give those fighters the legs to finish the fight. Without them, none of this architecture stretches across continents. And here's the truth that we sometimes forget in technical breakdowns. While the architecture is built by engineers and computers, it's executed by people. Those stealth coatings didn't decide to launch. That ASA radar doesn't evaluate risk. And the data bridge. It's the individuals inside under those aircraft at 2 a.m. that do. And this is where the story becomes bigger than a single strike. Because what happened on February 28th wasn't just a display of technology, it was a demonstration of training, discipline, and confidence in a system that demands precision. Which brings us to the final question. If this architecture worked, if fifth-generation aircraft shaped the battlefield before sunrise and absorbed retaliation after, what does it mean for the future? Because this morning may have marked more than an escalation, it may have marked a shift in how high-end wars are fought. While the visible part of Operation Epic Fury was kinetic, the decisive part was invisible. The F-35 Lightnings dismantled coherence, the Raptors erased uncertainty, and together, they were more than just fighters. They were keystones in a system that's designed to compress time, dominate the first hour of war, and make resistance nearly impossible. And that's the through line. At the end of the day, Operation Epic Fury wasn't won by ordnance, it was won by architecture. This morning may be remembered for the smoke rising over hardened targets, but history will likely remember something else. It could be the moment that fifth-generation aircraft finally proved they could penetrate, blind, deter, strike, and defend, all inside a single operational cycle. So here's the question for you. If this is how the first hour of war now looks, how do adversaries counter it? Because believe